Okay, so we were talking about how to find the horizontal and vertical asymptotes, and if there's a slant asymptote. So we're kind of looking at the cases for that. That's where we'd stopped. We hadn't gotten to practice that yet. Remember, finding the vertical asymptote is usually the easiest thing to do, the most straightforward thing to do. So and that was all about setting that denominator equal to 0. Okay, so that's where we're going to start on each of these. It's going to look at the denominator each one and set it equal to 0. Okay. So remember, the vertical asymptote represents that part of the graph where the graph starts to curve away from it, right, or curve along next to it. It doesn't want to actually hit that value of x because that value of x would make the denominator 0, and we can't divide by 0, so it makes the whole problem go. So set the denominator equal to 0. Of course, it's usually pretty easy. X plus 2 equals 0. That means x is just negative 2. So there's our VA, negative 2. The horizontal asymptote's a more complex relationship. It deals with the degree of the numerator and comparing it to the degree of the denominator, and then seeing what happens there. And if it's certain cases, it'll give us horizontal asymptote of this. In certain cases, we'll give a horizontal asymptote of that. In certain other cases, we get a slant asymptote. So we have to go and look at the degree of the numerator and compare it to the degree of the denominator. We can see here the degree of the numerator is 2, and then the degree of the denominator is 1. Okay, and so for what that means, right, when the degree of the numerator is higher, okay, and higher in a very specific way. So here the first one was if it was lower. So that's not that. Here it was if they were the same. It's not that. So here it was if it's higher, but it's 1 higher. Okay, so if it's 1 higher, then we get a slant asymptote. If it was 2 higher, we wouldn't see that. And that's not something that we're going to see, okay? But we wouldn't get a slant asymptote. It would be something different, okay? But we aren't going to see anything like that, not above our pay grade. So it actually means since it is higher, there is no HA, okay? This graph would not have a horizontal asymptote. What instead we have is a slant asymptote. So because this plus 1 is that, right? Since the degree of the numerator is 1 more than the degree of the denominator, that means there's a slant asymptote. So how do we find that, right? So it's going to come to us as like an equation, like a line, right? Y equals mx plus b is what we're going to get out of this. And so where that comes from is you take the numerator and you divide it by the denominator. And we use synthetic division to do that. And once we do that, we ignore the remainder. We take the constant and the x term coefficient, and we write that slope-intercept form of that line. Okay, so we use synthetic division, ignore the remainder, use your constant and your x term to get the slope-intercept form of the slant asymptote. I'll bring that back over here. I have 3x squared, I have 2x's, and I have negative 4. Or it says x plus 2, so we're going to bring that negative 2 that we talked about earlier, right? That guy again. We need the 0 of that to be our divisor over there. Drop your 3. 3 times negative 2 is negative 6. 4, we get to negative 4 when we add. Negative 2 and negative 4 give me positive 8. That gives me 4, but I don't really care about that anyways. That's my remainder. Here's my constant. And here's my x term. So the slant asymptote is going to be at y equals 3x minus 4. If we were going to draw that one, it would look something like this. We have to see that negative 2 vertical asymptote. Here would be our 3x minus 4. It would do something kind of like this. Didn't draw this very well, but then we'd have like a curve, probably like up in here. Maybe one up in there, and there'd be another one down here. I didn't give myself enough room, but it would look something like that. But we'll do that more formally later. Okay, it would look something like that. This next one's really easy. So find that VA, look at the denominator, set it equal to 0. So that'd just be x equals 2. For the HA, you look at the degree. So here our degree is 1. Here our degree is 1. Good Lord, what am I doing? Okay, so what happens when they're the same? Right, so go back up to our little rules up here. So when they're the same, this is not the same. Here's when they were the same. So when they were the same, what we did was we looked at the leading coefficients of the numerator and the denominator, and we ended up dividing those. So because these are equal, we now have to look out here to see what these are. And that'll tell us what the horizontal asymptote is at. So we can see that our leading coefficients are both 1. So that'd just be, y equals 1 over 1, which of course is 1. So if there's a horizontal asymptote, that means that there is no slant asymptote. So those things do not coexist. I can have a vertical and a slant, I can have a vertical and a horizontal, I can't have a horizontal and a slant. It does not ever happen. So that one was pretty easy. A little bit trickier. Find our vertical asymptote by setting that equal to 0. So x cubed minus 4x equals 0. What was it? Okay, so set that equal to 0. We need to solve that. So in order to solve it, we need a factor. Right, you should see that there's an x in both terms there, so we're going to take that x out. So it's x squared minus 4 equals 0. That's the difference of squares in there. So x plus 2 and x minus 2 equals 0. So then each one of those gets set equal to 0. So x equals 0, x equals negative 2, and then x equals positive 2. So this one actually has 3 vertical asymptotes. I've never actually graphed one that has 3 vertical asymptotes, or if I did, I've blocked it out due to post-traumatic stress. But we had definitely done 2, and you guys, if you guys done this last year, COVID hadn't come, we would have seen it when there's 2. We'll do one that's got 2 later, but so you can have 3, you can have 4, you can have 20 vertical asymptotes, right? But we usually won't graph above 2, so but they exist. That's all we're really seeing here. Some simple factoring there to do that. The horizontal asymptote, and that's all about the degree of the numerator compared to the degree of the denominator. So here our degree is 2, here our degree is 3. So they're not equal. So it's not the middle one. It says if the degree of the numerator is less than the degree of the denominator, which is what we have, that meant the HA was 0. So just hard and fast. If this number is less than that number, the numerator is less than the denominator, horizontal asymptote is at 0. So pretty easy. It's just kind of following the rule. Okay. And if there's a horizontal, that means there's no slant. So. Anything there you guys want to talk about? All right. Last one. All right. BA. Then we'll start graphing. I'll actually start applying this. So just working on these. So x squared plus 1 equals 0. So I'm going to solve for x. I'm going to get the x by itself. So x squared equals negative 1. And we go to square root that. We get plus or minus. And then the square root of negative 1 is I. So I is not a real number, right? So those are not real. So the idea of what we're up to here, right? We're trying to find the numbers that don't work, and then why there's those vertical asymptotes is, when that graph starts getting close to that, it starts to, it seems like it's kind of peeling away, trying to avoid hitting that line, because we don't want to divide by 0. If I plug in 0 into this problem, the denominator will become 0, and we're not allowed to divide by 0. Right? If I plug in -2 or plug in +2, the denominator will become 0. It's not okay. So if we're identifying the numbers that don't work in this problem. I can't plug these numbers in, they will create asymptotes. Well, the numbers that we can't plug in are imaginary. So there are no real numbers that we could plug in that will make this become 0. So what that means is that we can plug in any real number. Okay? And if we can plug in any real number, that means there's no break in the graph, which means there's no discontinuity, which means there's no asymptote. So this graph would have no vertical asymptote. Okay? Because this is not real, we get no VA. Okay? So remember, what you're trying to do here is find the numbers that don't work. I can't find any numbers that don't work, so that means all numbers do work. Okay? That graph will be able to go from left to right with no break in it. Horizontal asymptote is about finding answers that don't exist. So this is saying here we would never get 0 as an answer to this problem. Here we would never get 1 as an answer to this problem. We get all the other numbers as answers, but we never get 1. We get all the other numbers, we never get 0. So are there answers that never come out? Right, it's kind of the question here, right? What numbers can't I put in? What numbers don't come out? Right, and it's about the degree. So degree is 2, the degree is 2, right? And if the degrees are equal, then we go to look at the coefficients. I got a 3 and I got a 1. So y equals 3 over 1, which of course is just 3. Okay? So y equals 3 is our HA. So here it's saying that 3 would never be an answer to this problem. I could plug in every number I want, but I would never get 3 as an answer. So what does a graph with no vertical asymptotes look like? So we do know it has a horizontal asymptote at 3. What these graphs end up looking like usually is like this. They will scoot along that horizontal asymptote, and then as they head towards the y-axis, they start to just kind of lump up, and they lump back down, and they scoot along the asymptote again. The graph would look something like that. The lump could be upside down. How much it lumps changes just depending on the graph. Really about this ratio, right? Okay. So it could be a really flat lump, it could be a taller lump, but that's all they really look like when they have no vertical asymptote. So usually pretty easy to graph. Okay. You guys ready to graph? Yay! Oh, I love your enthusiasm, guys. All right, so flipping to the next page, there's kind of like steps-ish here, okay, kind of guidelines on help you graph these things. So there are more complex graphs, than especially like graphing like a quadratic or something like that. Okay. So we're going to look at the domain, right? What x values are we not allowed to use? And that, that question really is tied to those vertical asymptotes. Okay. So find those numbers that don't work. Those are the vertical asymptotes. There is over on page 76, there's some kind of special cases. We're not going to get to those today. Okay. If we do those, we'll do those later. Any horizontal slant asymptotes, of course, we want those. This will be, kind of new for us here that we haven't talked about this yet, but finding x and y intercepts is usually helpful if they exist. So sometimes they don't cross the x-axis or the y-axis. Just depends. And then we want more points, right? In the end, when we graph anything, we want points. Okay. So I'm trying to get you guys to have the first 3 things there on that list are really kind of prescribed. If you want to find the vertical asymptote, do this. If you want to find the horizontal asymptote, do this. If you want to find the x and y intercepts, do this. Finding points is more of an art, more of a feel thing. Like, what do I need to, what numbers do I need to plug in and stuff like that in order to get more information. And I'll try to describe to you guys like how I think about that. So a little note here says that they never intersect the vertical asymptote, but they may intersect the horizontal or slant asymptote. So what that ends up looking like if they do, so if I have a problem, here's my vertical, here's my horizontal, and if my graph, so maybe on this side of this top left corner, it does something like this, and it looks pretty normal. It's just kind of sitting there in the corner. And maybe over here, as I'm drawing it and I'm plotting points, like I get a point here, and then I get a point up here, and I have another point. So I've plotted some points, okay? And I've gone back and I've double checked my math, because I'm like, ooh, why did it go across the asymptote like that? So I've gone back and I've double checked my math to make sure I didn't miscalculate something, but that's the way it came out. So what can happen is that it'll kind of like lump up above the asymptote, but then in the end, as we head off towards the right, it'll curve back down. Okay. The asymptote is not a line that we don't cross. It's something that's like a easy thing to say. It's you don't cross that line. The actual definition is that it's the line that the graph goes towards as we head towards infinity. So as we head to the right, it's going to get closer and closer to that. It won't cross back down, okay? But it can go up above, and then it will come back towards it. Or, again, the more normal thing that we see most of the time is that it just comes and then sits below it, okay? But it is okay if it like lumps up above and then you can see that. But I don't know that we'll really see it that much, and there's really no way to know that that's going to happen until you get values. So it's nothing that you need to like stress about. Okay, so we're going to do those kind of, find the asymptotes, we're going to find their intercepts, then we're going to get some more points. And I always start with the vertical asymptote. It's the easiest thing usually. So here, VA, so I want to set that equal to 0. So of course, that'd be -6. Yeah, and as soon as I get a piece of information, I'm going to put it on my graph. HA, that's our degree comparison. So degree equals 1, degree equals 1. So since they're the same, we go to look at the coefficients. And their coefficients are both 1s, right? So y equals 1, right? 1 divided by 1 is our asymptote there. Next thing I asked about was x-intercepts. What do we know about every x-intercept that ever was, every x-intercept that ever will be? How do we find x-intercepts?
Y is always 0.
You say that again, sorry?
Y is always 0.
Y is always 0, right? So it's something 0, right? So yeah, that's what we know, right? And so where's our y, right? Our y is the r of x. So that r of x becomes 0. So we have 0 equals x minus 3 over x plus 6. Okay, so we set y equal to 0 and we solve for x. Well, we can't solve for a variable when it's in the denominator like that. Can't solve for a variable when it's in the denominator like that. So how do we get that x plus 6 out of the denominator? How do we get that x plus 6 out of the denominator? Don't even multiply the reciprocal, right? Just multiply by it. Yeah, right, Victoria, just multiply by it. So we're not trying to move the whole fraction, right? We just want to move the denominator out. So we're going to multiply both sides by x plus 6. So what happens to the x plus 6's on the right side?
They cancel out.
Yep, cancel out. Those are gone. What happens to the x plus 6 in the 0 over here? What happens on the left side?
Wouldn't it just be x plus 6 equals x minus 3?
Mm-mm.
Mm.
What are we doing here, Victoria?
Oh, multiplying, so it'd just be 0.
There you go. Yeah, so we get 0 equals x minus 3. And that's going to happen every single time, guys, right? These functions all look the same, essentially. It's a function over a function. There's always going to be a variable in the bottom. That's what makes it a rational function. And I can never solve for a variable in the bottom. So the very first thing I have to do is move it to the other side. And that other side is always going to be 0, because that's what we said. Y had to be 0. So every single time you go to find the x-intercept, this same thing is going to happen. So instead of setting up this big equation that we have to do all this stuff to, if we instead just say, hey, what's going to happen every single time, right? Let's just set the numerator equal to 0, right? So to find the VA, we found the numerator equal to 0. What's that equal to? To find the x-intercept, we're going to set the numerator equal to 0. Did I say numerator twice? I might have. Find the VA, we set the denominator equal to 0. That's our vertical asymptote. To find the x-intercept, we set the numerator equal to 0. And that'll be our x-intercept, okay? So you guys don't need to sit here and write these equations out and then multiply them and get 0 each time. Just take advantage of this. That's how you find x-intercepts, please, okay? So of course, x equals 3 here. So our x-intercept is at 3, 0, okay? So I'm going to go ahead and plot that point. There's that x-intercept. Now what about y-intercepts? What do we know about every y-intercept that ever was, ever will be? Yep, x is 0, right? This one's easier. So essentially what we're doing is plugging in 0 for x, which is 0 minus 3 over 0 plus 6, right? So it's just negative 3 over 6, which is negative 1/2. So 0, negative 1/2. So finding y-intercepts is really easy. So 0, negative 1/2 would be right in there. Okay. So we see that vertical asymptote, which again represents the part of the domain that can't happen, right? The only number that we can't plug into this problem is negative 6. We see the horizontal asymptote, which represents the only answer that won't come out. We'll get every number as an answer except for 1. Okay, so what can't we plug in? What won't come out? We have 2 points. I tell you guys that you should really have at least 6 points on a rational function to get a good idea. What we need is points on the right side, and we need points on the left side of that asymptote. Okay? And what we can't do is like when we did the quadratics, if you graphed one side of the parabola, you just flip it over to the other side. These don't have y-axis symmetry normally, so we can't do that. Okay? We just have to plot points on one side and plot points on the other side. Generate points on one side versus the other. Okay? So I told you this was more of a feel thing. Okay? We do know we need some on the left and some on the right, but where do we, what x values do we use? So it is similar to the quadratic stuff when we had that line of symmetry. I talked to you guys, let's get some points right here, let's get some points right here. We don't want to be way over here collecting points. Okay? It's kind of the same thing. We want points near the asymptote because that's where all the action is. Okay? When these things curve, they curve right in this space. They don't curve way out here. That part's pretty flat. They don't curve down here either. That part's pretty straight down. Okay? This is the space we want information in because that's where the turning is happening. Okay? So generally I want stuff that's pretty close to the asymptote. So I'd usually say within like 2 spaces. So like negative 5 would be a good number to have a point at, and negative 4 would be a good number to have a point at. Okay? I'm also going to take advantage that I do have those out there. So I don't need to get points that are further away. But I do want to know what's going on at negative 5 and what's going on at negative 4. Okay? So in the same way, I want to know what's going on at negative 7 what's going on at -8. Okay, and then I'm going to go ahead and plug in -10 just to see what is happening further away. So again, just from my experience with this, guys, you want a couple that are close to the asymptote, and then you'd like probably just one that's further away. Okay. So I'm picking 2 that are close, and then I already have these that are further away, so I don't need to do that math. Okay. I'm picking 2 that are close, and then I'm picking one that's, well, that's as far away as I can get because my graph is all squished over to one side. I'm picking 2 that are close to the asymptote, and then one that's further away. Okay. And that's just kind of the feel of it that I think I would suggest you guys follow. Okay. And from here, it's just kind of working through and getting those answers, right? So I'm just going to set up a table. If you guys want to use your calculator to get these answers, you want to use your brain to get these answers, I don't care. You just need to plug in these numbers and get y values out of them. Okay. So I'm just going to do it by hand though. They're pretty easy. So I'm going back up here and I'm plugging in -10. So -10 minus 3 is -13. -10 plus 6 is -4. So I get -13 over -4, which comes out to 3.25. Okay. Plugging in -8. So -8 minus 3 is -11. -8 plus 6 is -2. So I got -11 over -2, which is 5.5. Plugging in -7, I get -10 over -1, which of course is 10. I'm going to go ahead and stop right there, and I'm going to go ahead and plot those 3 points because those are all on the left of my asymptote, so I want to go ahead and get that left side of the graph drawn. Okay? I don't have to stop right here. I could go ahead and get all the points and do the graphs at the same time. I just like to do one side and then do the other. So, okay. So I'm going to plot those 3 points. So -7, -10, it's way up there at the top. 5.5, and -10, 3.25, somewhere in there. So I've plotted my 3 points here. Okay. Now this piece is pretty shoved off to the side, so we don't get to see as much as we normally would. The idea is that as we head off to the left, the graph should be getting pretty close to the asymptote, should basically kind of be running flat along that asymptote there. Okay, as we head off to the left, it goes off in the same way as it heads up, it should be running pretty much flat along that vertical asymptote. Okay, so as I go to try to draw it, I'm just going to kind of follow those rules, so those ideas, and then say, okay, oops. So I'll curve down through those red points and kind of start to flatten off as I head off to the left. Okay, so as you head off to the left, it should start to flatten. You don't want it to keep going down like that. It's not a line. Right? It should start to curve along that horizontal asymptote. We just can't see it because it's all pushed off to the side. And again, it's the first time most of you have drawn a rational function. So then I want to plug in -5. So -5 minus 3 is -8. -5 plus 6 is 1, so I get -8 here. Plugging in -4, I get -7 over 2, so that'd be -3.5. So I notice that these two are negative, which is actually good because on that right side we already had points below the x-axis or below that asymptote. So I don't want, if those points had come up here, that'd be kind of me going, I really need to check my math because again that'd be crossing that asymptote, which doesn't happen a lot. Can happen, but doesn't happen a lot. Okay? So if I'd gotten positive numbers, I really would double check my work, go back. Okay? Because I got negative numbers and I already had negative numbers or lower numbers, right? That I'm okay with that. So, okay. So then -5, -8, -4, -3.5. So again, as I go to draw that, I want that part that's down and going down should run pretty much next to the asymptote, parallel to the asymptote. Off to the right should run pretty much parallel to the asymptote, and my job is just to curve it between there. Okay. It doesn't matter where you start, just kind of figure out what feels good to you in your drawing. Ooh, that was pretty. You guys are lucky to see that one. So there's a hyperbola. If they ask you guys to do the domain, I don't believe they usually want them in interval notation. What they talked about was, I saw was, they talked about set notation. I'd say the x is a member of all real, or element of all the real numbers. And then they say, I think they usually just ask like, what number couldn't you use? I remember that's all about that asymptote. Right? We can't plug in -6. So you would just say, I think it even has most of it typed out for you. It just says, what number can't you use? And so you would just say, you can't plug in -6. So, in the same way, if you wanted to do the range, it would just, be, y would be the element of all the real numbers, except 1. You can get every number out of there except for 1, is what that would mean. And it's really what these things you guys need to focus on, which is these. Anything there on that one you guys want to talk about? You guys ready to move on to the next one? Need time or anything? Okay. I drew that yesterday. Get rid of that. Tuesday. Let's see. Okay. So example 3 here. A little oddly, they went ahead and factored it for us. I would not expect that, for you guys to see that already. So more likely, if they gave this to you, it would look like this, where it's not in its factored form. So if we FOIL the denominator back out, we get x squared plus x minus 2. If we FOIL the numerator out, we get 2x squared plus 7x minus 4. So this would be the way it would normally come to you guys, where it's not factored, it's in its standard form. And then you guys would factor it in order to do the stuff that you would need to do. So generally the first thing you'd want to do is go ahead and factor everything. If you had a complex problems like this, or complex polynomials like this. The last one wasn't factorable, so we didn't need to worry about it. Okay. I would expect it, again, normally you guys would see it like this, the standard form, you would need to turn into factor. But none of the factoring is going to be crazy. We see an easy AC here, we see a long AC, but it's still not a difficult problem. Difference of squares, GCF, like real basic factoring. There won't be any grouping or anything like that. So shouldn't see any where there's a whole bunch of factoring to do, where you have do a GCF and then a difference of squares. It shouldn't be like that for the problems that we're going to do. So VA, right? Want to look at that denominator. All right, if I'm going to solve that, set that equal to 0, I'd want it factored. So, so we'll take advantage that they already factored it for us. So our VA, well, this piece here is going to have its own 0, so that'd be x equals -2. And this piece would have its own 0, which would be 1. So this graph would have 2 vertical asymptotes. Okay. On your homework, you guys don't have any that have 2, so you don't need to worry about that. But I just want to show you guys what it looks like. And on your homework, any graphing you guys do will just be multiple choice. You need to pick out the graph. So you'll use the asymptotes, you'll use the x-intercepts and y-intercepts to eliminate stuff. Like, oh, these don't have the asymptotes in the right place. That one's gone. This one, the y-intercept is not in the right place. That's gone. Okay. So use your process of elimination stuff there to figure that out. Horizontal asymptote. I really think the horizontal asymptote is easier to see from standard form, because remember, it's all about the degree of the numerator compared to the degree of the denominator. That's easier to see when it's already multiplied out. You know, if it was in factored form, I would just see how many x's there are on the top. There's 2 x's. That's why the degree is 2. Okay. You know, there's 2 x's here. Okay, that's why the degree is 2 on the bottom as well. Okay, so they both have the same degree. Okay, so that didn't change anything. So when they're the same, remember that means we have to go and look at the coefficients. And the coefficients, I think, are easier to see when it's in standard form, because now I can see it's 2 over 1. If I want to find the coefficient here, I'd have to take 2x times x, which would be 2x squared, so I'd have 2. And I'd take 1x times 1x, which would give us a coefficient of 1. So I'd have to just make sure I look everywhere, say, okay, this would multiply to be 2, this would multiply to be 1. Okay, it's 2 over 1. Again, it's easier to see here. So y equals, 2 over 1. So y equals 2 is our horizontal asymptote. Go ahead and draw that in. So there's just certain ways that these multiple asymptote problems look, just from all the experience I've had with them. Generally what we see would be like often either the top left or the top right, or sorry, or bottom left, top left or bottom left, there's like a hyperbola looking piece. So it might be there or it might be down here. We don't know yet, but it's just something like that. And then on the right side, either top, so there can be 2 on the top like that, or it might be 1, on the bottom like that. So there's usually something that looks kind of like a hyperbola, but it's on the outsides. In the middle, what we usually end up with is kind of a wonky looking parabola, like it might be kind of wobbly, like bent, squished in the middle. We can have this like parabola looking thing, or we end up with this like S curve that goes through the horizontal asymptote. So this middle piece can actually ignore that horizontal asymptote completely, just like completely pass through it. But it will be bound by those vertical asymptotes. So that's just kind of what I've noticed, like all the hundreds of times that I've done this, in my math teaching career, that's the way these look. Okay, so just kind of giving you an idea of like where we're headed. Okay. So let's get some more points, right? We want to go ahead and get our intercepts. That's the word I was looking for. So just like last time, we're going to find the x-int by setting y equal to 0. But when we do that, and we talked about that really means we can just set the numerator equal to 0. Take advantage of that this time. Figured that out last time. So 0 equals, and I'm going to go ahead and, since they factored it for us, I'm going to go ahead and take the factored form. So set that equal to 0, add the 1 over, divide by 2, x would equal 1/2. Set the next one equal to 0. Or subtract the 4 over, we get -4. So I get 1/2 0 and -4 0 are my 2 x-intercepts. (1/2 0 and -4 0. That, not that, right? So I plotted my 2 x-intercepts. Y-intercept, that one was easy. Means that x is equal to 0. So we'll go ahead and use the factored form. It really doesn't matter which one you use. They're both actually pretty darn easy. You go ahead and just use the factored form though. So plugging in 0, so 2 times 0 minus 1 times 0 plus 4 over 0 plus 2 times 0 plus 0 minus 1. You don't be silly here and like sit there and try to FOIL that out or anything like that. Just simplify what's in each set of parentheses. 2 times 0 minus 1 is -1. 0 plus 4 is 4. 0 plus 2 is 2. 0 minus 1 is -1, right? And on the top I have -4, and on the bottom I have -2. -4 divided by -2 is just 2. Okay? So our y-intercept is 0, 2. So just plug in 0, then simplify it down. Don't make it more difficult than it is by like trying to FOIL or something like that. 0, 2, and you actually see that that actually sits right on top of the asymptote. So this one's definitely not going to pay attention to that horizontal asymptote in the middle there. So those 4 things that we just did are kind of prescribed. Here's how you find vertical asymptotes. Here's how you find horizontal asymptotes. Here's how you find x-intercepts. Here's how you find y-intercepts. Right? The rest is kind of a feel. What numbers do I need in order to kind of finish this up? Okay, where do I need information to finish this graph? Okay, where don't I have points? Where do I have points? Okay, just kind of taking that in and saying and figuring it out. Okay, we need something on this left side. We have 1 point. We need stuff on this right side. We don't have any points. We need something in the middle. We have 2 points. Okay. Again, those left and right pieces are going to look pretty much like hyperbola. So if we can do 3 points for each one, we're pretty good, just like we done in the last problem. Okay, so on those outside pieces, I'd ask you guys to get 3 points. On the inside piece, it can be really weird looking, so the only way for us to kind of help ourselves there is to get as many points as possible. Usually there won't be that many points there because the space is pretty narrow. Okay, so I really just try to get as many points as possible on that inside piece. But on the outsides, I want at least 3. Okay, so looking at what I have on the left side, I already have -4. My asymptote's at -2, right? So I have a gap here, like I don't know what's happening at -3. So I want to get some information about -3. So that would give me 2 points that are right next to the asymptote. So I'm going to get something that's further away. Okay, so I'm also going to get -8. Okay, so I'm just getting something further away. I flip over to the right side, our asymptote's at 1, so 2 would be a good number to have, and 3 would be a good number to have. So I'm going to plug in 1, I'm going to plug in, not 1, I'm going to plug in 2, I'm going to plug in 3. Then I'm going to pick something further away, okay, like 6. And then when I look at the inside, I've already got 0, and I've got half. The only other integer I have here is -1. Okay? I'm not going to make you guys plug in like -1.5 or anything like that. Okay? I'm just looking to see what integers I have available to me here. The only one I have is -1, so that's all I'm going to plug in. And that'll give me 3 points on the inside. I should be able to kind of tell what's going on. Okay? So the rest is just going to be evaluating these points, right? Plugging those numbers in and getting our answers. You guys have any questions about how I picked the numbers I'm going to use? Grant, are you awake?
What's up?
I was just seeing if you're awake. I know what my voice does to you.
That's true. I think it's that screen in your room.
Okay. All right. We'll blame that. So I'm going to plug in -8. I'll plug in -3, and I'm going to plug in -1. I know it's -1's from a different section, but I'll still just plug it in there just because I got space. And I'm going to plug in 2, 3, and 6. Okay, and I'm going to do this one, all this stuff by hand, mentally. You guys need to plug in your calculator. And it doesn't matter which form you use. Like I know we came up with this one. Okay, realistically, guys, you should use the one that you were given, because if you were given this one and you made mistakes as you factored, right, easy enough to do. Okay, and you start plugging in your points. You made mistakes in your factoring, and then you used all your factoring to get all this information. Okay, you used all the factoring to get all this information. And then you go and you plot those points and those asymptotes and all that stuff. And then you start using your original equations to get points. If you made a mistake in your factoring, your points and your asymptotes and all that stuff should not make any sense. So it would basically let you know that something went wrong here. So you should always use the original equation when you go back to plug stuff in, just in case you made a mistake somewhere in this stuff. It'll kind of let you know that something is not feeling right. Okay. So to that end, I was about to say that you could use either one, but you really should use the original. So again, you want to sit there and basically burn all these out. So I need to plug in -8, which is going to be -16 minus 7, so -17 times -4, which would be 40, 68. So 68 over -8 plus 2 is -6, and -9, which would be 54. I guess 68 divided by 54. It's 1 point something, right? 1.25-ish, or 1.2, 1.3. Plug in -3, you get -6, -7, and 1, so you get -7 over -1 and -4, so that'd be 4. -7 over -4. No, wait, that's not right. So -7 over 4, which is -1.75. So that was both of these points off to the left side here. So I'm gonna go ahead and plot those. So that lets me finish this up. That way I can just go ahead and knock this part out. I'm gonna come along that vertical asymptote. Try to curve through those points towards my horizontal asymptote. Not a good looking one. There you go. Should look something like that. I'm gonna go ahead and do the right side because that's the easier side than the middle. The middle is again kind of the weird spot. So I'm gonna go ahead and just do a bunch of math here to get the right side done. So plugging in 2, I get 4, 3, 6, I get 18 on top. 4 on the bottom, that gives me 4.5. Plugging in 3, I get 6, 5, 7, 35 on top. 5, 2, 10 on top bottom, 3.5. Plugging in 6, I get 12, 11, plus 10, so I get 110. 8, 5, 40. 110 divided by 40 is whatever 11 divided by 4 is. 2.75. So now I can do the right side. And you start to see the curve, right? It's going to move along the horizontal asymptote, curve up along the vertical, just drawing this shape here. So it looks pretty much like a hyperbola there, right? But it's got something weird going on in the middle. So we just need to figure out what -1 is. So -1 times 2 is -2 minus, so it'll be -3 times 3. So it'll be -9. And then 1, -2. So -9 divided by -2 would be 4.5. So -1, I get 4.5, which is up here. So plotted that point there. So again, weird things can happen in here. You know, if you kind of look at what's happening in these, you know, if I go from left to right, it looks like the points are dropping. You know, doesn't seem like it would turn around for any reason. Same thing if I go the other way, it doesn't seem like it would drop down. Like the graph wouldn't, you know, most likely would not do that. Just all of a sudden hook real sharp down. Okay, so those points seem to be kind of going in a pattern as we're going from the left side to the right side, they seem to be dropping. So if I follow along that vertical asymptote towards the top, I'm going up and to the left, and then down through those 3 points, and down to the right. Most likely what that looks like. So kind of a S curve, a flat S curve there in the middle. Again, without really knowing for sure like what's happening here at like negative 1.5, I don't know for sure that's what it's doing, but most likely that's what's happening. It's tending to go up as I go to the left, so most likely it'll keep doing that. But it could turn around, but most likely it's not going to. That's a pretty tricky one. Okay. Tomorrow is our work day. If you guys want me to go through another example, I certainly can.